Our next presenter is Bill Robert from SpyPond Partners. Mr. Robert works as Vice President at SpyPond Partners, a transportation consulting firm based in Arlington, Massachusetts. There, his work focuses on implementing transportation asset management systems and approaches. Recently, Mr. Robert served as Principal Investigator for TCRP Report E-09 on transit state of good repair. Previously, he worked on a variety of projects to analyze asset investment needs, develop performance measures and models, and design and develop management systems. He is a member of the TRB Asset Management Committee and of the TRB Transit Management and Performance Committee. Mr. Robert obtained his master's degree in civil engineering and his bachelor's degree in physics, both from MIT. Now I will turn the presentation over to Bill.
Okay, thanks very much. Again, I will be presenting on the results of a recent TCRP project, Project E09, and I'll be talking about prioritizing and evaluating implications of investments in capital assets for rehab and replacement. And this slide shows an overview of what we'll cover. I'll give a brief description of the TCRP project that we finished up, discuss the literature review that we performed, state of good repair related literature, and also existing practice from interviews and other information sources. Discuss how we relate state of good repair to performance, and then present a framework for transit asset rehab and replacement. And finally, I'll briefly describe some tools we developed as part of the project that give transit agencies an ability to evaluate and prioritize asset rehab and replacement decisions for a variety of different asset types. So first, to say a little bit about the TCRP E09 project, the objectives of the project were to first develop a framework for public transit agencies to use to prioritize asset rehab and replacement, and second, identify methods for either assessing the consequences of different investment levels or prioritizing investments. So basically, we had a framework that we wanted to develop and then a set of tools that illustrate the framework. We had a big team involved in the work, and they all played important roles on the project. So Kay O'Neill from KKO and Associates helped out, as well as individual consultants, Harry Cohen and Joe Barr. And I won't go into the gory detail on the project, except to say we broke it out into two phases. The first phase was really to look at what was out there in terms of state of good repair literature, and to do a set of interviews to supplement the literature review. And then in phase two, we developed the framework and the tools. With respect to the review approach, what we did was first looked at asset and transit management literature from the past decade or so. We looked at TCRP and NCP and other TRB research papers and reports, as well as other information that we came across from literature search. We included in our review the first couple of FTA State of Good Repair roundtables. The review was completed prior to the last roundtable from last summer. We also looked where we found information, looked at agency websites to see if there were additional reports or information sources that were available. All this was very useful, but then we knew that there was a lot that agencies are doing that wasn't really captured in the literature. So we also performed a set of 11 agency interviews as part of the research, either to find out more from particular agencies where we knew that there was something they were doing that was of interest, or to help fill in gaps with agencies that perhaps there was some information published, but we wanted to get a little bit more information. So we talked to 8 U.S. transit agencies, a couple of highway departments to characterize existing practice and best practices in the state DOT community. And then we also spoke to one international transit agency, London Underground. Key findings from the review are listed in this slide. What we saw was that in terms of what people are currently doing, the main measures that people are looking at when they perform state of good repair analyses are cost to perform recommended work and asset age or remaining life. And so what do I mean by this? Well, when Lauren and David presented their results, they showed you a graph from one of the recent FTA studies, and that showed you essentially a backlog estimate across different asset types. So that's a great example, one of the best examples of an analysis that has been performed of state of good repair needs. The other approach that you see is average age of the assets or remaining life of assets. So those are the most common measures. We also saw from the review that there are a lot of definitions of what we mean by state of good repair, and really no consensus in the literature on what the definition is or should be. For our research, we're not trying to define what we mean by state of good repair. Really, we were focused on the issue of trying to go beyond just having a definition and saying the cost to achieve a state of good repair to characterizing the effects of investing at a given level of performance. So we weren't particularly concerned with the fact that there's all these different definitions, but it was an interesting result nonetheless. There were a number of good analytical approaches that have been used in the transit industry in the U.S. and Europe. Several good examples in the U.S., and I'll talk about those a little bit further in the presentation. And then in Europe, there was a recent international review that was performed that was good. And from our interviews, we also got some good information about international practices. Here in the U.S., there's a lot that's been done on the highway side, particularly for pavement and bridges. And these approaches are very applicable to transit. But then when we look at general guidance for asset management in the U.S., this general guidance has been largely geared towards highway. So there is something there to learn from, but it is very much geared towards highways. In some of the notable analytical approaches, Lauren and David talked about the FTA term model a little bit. So it uses a 5-point condition scale for assessing state of good repair. Assets are assigned a condition based on their age. So that's really the model FTA uses, and is one of the most commonly used models here in the U.S. And then two other U.S. examples: the NDPA State of Good Repair Database, which the T uses for prioritizing funding. It's also been used for a number of different agencies. And the NCC has a useful approach as well. The Regional Transit Capital Inventory is used by NCC to help analyze state of good repair needs for Bay Area transit agencies. And the approach it uses is conceptually similar to that term, slightly different measures, but same basic concept. And then internationally, the one approach we thought was very notable was the use of lost customer hours by London Underground to characterize state of good repair impacts across different asset types. The next step of our research was try to relate state of good repair to performance. So going beyond the simple definition of what is or isn't a state of good repair, and trying to say, well, what does achieving a state of good repair mean in terms of performance? And the outstanding example of this here in the United States is New York City. In the 1970s, there was huge budget problems, obviously, in New York City, and steep decline in condition of the transit system, and then followed in the 80s and 90s, and more recently, by just a great success story in terms of restoring the condition of that system. So in the 1970s, over a period of about 10 years, the between failures for the subway system dropped from 23,000 miles between failures, which by today's standards is not great, but it dropped to 7,000 miles, which is really not good at all. But now, if you look at the system, in some cases, some of the same cars, but largely a new fleet, the mean distance between failures is 156,000 miles. So there's really been a big change there. And then also, there was a big deferral in rail replacement. And by about 1982, over 50% of the subway system was classified as requiring rail replacement. And this all came with performance impact. So there was an 80% increase in delays over the 70s, and subsequently delays dropped 59%, 17% reduction in ridership, not just because of the state of good repair, but because of a lot of other things that were going on at the time. But subsequently, ridership grew by 58%. So this is a good example of the bad and the good that can occur when state of good repair is restored. In our research report, we have a number of other state SGR examples. So I won't go into detail on those, but I'll briefly describe them. Chicago Transit Authority, the Douglas branch, was a section of PTA's rail system now called the Pink Line. There was a partial closure of the line due to deteriorating conditions. Restored the service back in 2005, and similar, but on a smaller scale from what you saw in New York City. You had a deteriorating service and then followed by improved service and restoration of ridership levels and so forth. In Toronto, there was a big focus on state of repair following the Russell Hill accident that happened in the Russell Hill Tunnel in 1995. So after that point, Toronto really became a leader in addressing state of good repair issues. We didn't find any one example of state of good repair and effects on performance for bus-oriented agencies, but the FTA report, Useful Life of Buses and Vans, provided results from an interview of bus agencies regarding their experience on deferral bus maintenance. That report, Useful Life of Buses and Vans, is truly a very useful report. It had a lot of good information that we used for the TCRP EO9 study. So taking all this together, what does it mean? How do we relate state of good repair to performance? So what this figure shows is our view on this. Essentially, in the middle of the diagram, we see asset state of repair. And I would argue that having a good state of repair is, it's a good thing to achieve, but it's good because of what it means for performance. It's not good in and of itself necessarily. So we measure state of good repair in terms of asset measures, most commonly age and condition. And then those measures impact a number of asset-specific measures that are also shown on this, such as asset availability, service quality, reliability, and maintenance costs. And really, you want to keep your assets in a state of repair so that they're available, so that they provide quality service, so that they're reliable, and so you can hold down maintenance costs. As these things are impacted, then that in turn has system-wide impacts that are also important, although obviously harder to quantify. But and so the figure shows system performance, network capacity, safety, life cycle costs, and so forth. In the New York example, you saw all of those things flipping as assets fell out of good repair, and all those things improving as the state of repair improved. And then there's other indirect impacts. If the system is failing, you would expect that to have an impact on demand. It could have an impact on fare box revenue, and so the figure sort of depicts that relationship. So all these things, are obviously important. Ideally, we'd like to capture all these things: the asset measures, the asset-specific impacts, the system impacts, and their relationship on revenue and funding and so forth. But obviously, that's a very complicated set of relationships. So the implications of all this is that first, there's a strong but indirect relationship between the asset measures like age and condition and the system impact shown in the figure. So we do expect that if you fail to keep assets downstream, will have safety impacts and so forth. And also better analytic methods to predict some of the asset-specific and system impacts, also to relate asset conditions to performance and convert these measures to costs that you can use to prioritize. And finally, better methods are needed to help provide an economic justification for achieving a given state of repair. So it's not really enough in the grand scheme of things to just say we want to achieve a state of good repair. We need to try to go beyond that and try to show why that's an economically justifiable thing to do. And we think, of course, the evidence is there that it is, but it's another thing to show it. So in the report, we recommended some specific performance measures to use for analysis. The asset measures we recommended were age and condition, which are commonly used now. And we also recommended going beyond those measures and looking at some of the asset-specific impacts, including availability, particularly for assets like elevators or escalators, hours of delay where this can be calculated, maintenance costs, and then for characterizing things like improving the sustainability of a bus fleet, probably the best measure to use is the percent of assets that are enhanced or improved. Okay, so now I'll talk a little bit about the framework we developed as part of the initial research of the literature and impacts on performance of state of repair needs. So our framework had three basic elements. We looked at investment levels, so what money is available, looked at what rehab and replacement actions can be performed, and we also looked at the performance measures, in terms of operating costs, performance, other measures. And at the intersection of all these areas is really, the answer to the question, how should we prioritize investments, given what funds we have available and considering performance, of course, considering what things we can actually do. So this figure shows the framework, or shows the process, and this is the process for evaluating and prioritizing rehab and replacement actions. Basic steps in the framework: first, go out and get some data, and then analyze asset conditions and performance, generate specific rehab and replacement alternatives that one could perform on those assets, define scenarios for what might be done, and then use the information from the scenario analysis to prioritize project development plan, and then, obviously, most important, perform the work. And our research report, goes through in more detail all the steps and what some of the key considerations are on each of the steps, and certainly encourage everyone to take a look at that once it's published. It'll be TCRP report 157. I'll just mention a couple of examples of what transit agencies are currently doing that are illustrative of the framework. Obviously, they're not doing these things because they read the report. They're doing these things independently of any of our research, but they show exactly what we're talking about in terms of this framework for prioritizing asset rehab and replacement action. So the first example is the MBTA. MBTA has a couple of different things they're doing which are noteworthy, a lot of different things they're doing which are noteworthy. In this first example, when we talk about looking at performance measures and characterizing performance of the existing asset inventory, NCP has done a lot of work in this area, and they developed a one-page scorecard for reporting asset conditions, and shows a lot of different measurement types: ridership, vehicle system maintenance, on-time performance, schedule performance, accessibility and availability, safety, and budget. This is a shot of the dashboard from May 2011. You can see there that it's got a little panel for each of those measures. And then if you go on their website, they then proceed to break it down in further detail by mode and by line. Several agencies have established things of this ilk, and I think there's certainly great ways to communicate what the performance of the system is within the agency and to the public. So that was just an example of how to communicate performance and how to establish performance measures. There's a couple of good examples that I mentioned briefly earlier of analysis models. And really the two best examples we came across in our research, and there's, of course, there's been a lot of work in this area just in the last year or so. But first, the MBTA State Good Repair Database, and second, the NCP Regional Transit Capital Inventory. Each of these are notable for a couple of different reasons. The MBTA database has been used in the MBTA and also at other agencies to help prioritize what state good repair work to perform given a constrained budget. So by this I mean you can run this tool with a budget that's less than what you would like to have, and it'll show how money is stimulated and is being allocated. Now, the MBTA doesn't use the state good repair database to pick projects. So that when I say that it prioritizes work, it's within the confines of an analysis. They handle project prioritization as a separate process, and actually the approach that he uses, similar to the approach several other agencies use, is also a great example of best practice in this area. So both their state of repair database and the project prioritization approach are notable, and we describe those in the research report. The other interesting analysis model that we call out as an example in the report is this RTCI. And this one is notable in that it gets used across a whole bunch of different agencies. So what NTC and the Bay Area Transportation Transit agencies had to contend with is how to set up their asset definitions and types and categories so that everybody can collect consistent data. And then they use that data to do an analysis. Their key measure is APPLE, which is average annual percent of useful life remaining. And then, like the MBTA, NCC has established a separate process for prioritizing projects, again using a published set of weights on key objectives. One thing we recommend in the framework is developing some sort of plan. Once you've analyzed rehab and replacement needs, and King County illustrates this basic process. What King County Metro has done is they've established a transit asset management program for managing their fixed assets, so facilities and other fixed assets. If an asset is deemed to be within 6 years of requiring replacement or rehab, then King County will inspect those assets on a yearly basis and then develop an annual work plan based on the inspection results and considering the budget and other factors. And then a summary of this, the inspections and this analysis is provided in their transit facilities condition report, which is essentially an asset management plan. So that's all I was planning on saying on the framework, but I'll also briefly describe some of the analysis tools that we developed. So essentially what we were trying to do as part of the project was develop a few analysis tools that hopefully are very useful, but at a minimum will illustrate the framework. And what these do is help convert key measures of asset performance into agency and user costs. And then this information can be used to prioritize what rehab and replacement assets perform. So really there's three tools that we developed that analyze asset-specific needs. There's a vehicle modeling tool specifically for buses and rail vehicles. And then there's two other tools for all the other assets. We use data from term to develop default models, and these models are age-based and condition-based. So every asset has a model for either age, modeling the asset based on age or modeling the asset based on condition. And one might decide to use one or the other based on what data they have, essentially. And then there's a fourth tool, the prioritization tool, which uses data from the other three to rank projects and simulate the allocation of the budget. Anyway, what you see here is a depiction of the four models, but essentially the input to the models is shown at the top of the figure. So you put in a description of the inventory, vehicle age or condition data in case of the, and then you put in information on cost. And then each of the models will spit out information on what rehab or replacement alternatives are recommended and how might they be prioritized. And then all that information for a mix of different assets goes into the prioritization model, which will actually take a wag at ranking projects and allocating a budget. So here's the vehicle tool. So I should say that these are all Excel spreadsheets. So essentially, you open up this model. It looks very nice, but it's a spreadsheet. You select the vehicle type, be it a bus, light rail vehicle, or heavy rail. You put in a description of the vehicle. In the case of vehicles, we rely heavily on the National Transit Database, data definition. So that requires, for NTD reporting counts of vehicles and their accumulated miles. So you put that in, put in some other base year statistics, replacement costs, and then this slide shows what you get out of the tool, which is a cost minimizing replacement mileage, considering replacement costs, fuel costs, rehab and maintenance costs, delay costs from road calls and failures. The model also tells you the average annual agency and user costs, and then you get a prioritization curve. And what we do is we create what we call a prioritization index, which is essentially a ratio of the benefits of rehabbing or replacing an asset to the cost, and you see that tends to get bigger as the asset gets older. So if you replace the asset when it's recommended, when it's cost minimizing, the prioritization index is about 1, and then as you defer replacement, the priority tends to go up. And it's an age-based tool. Here is not as much input. You select an asset to use, and we use term data to develop default deterioration models, not for vehicles, since those are treated as vehicle models, but for guideway station systems and facilities. And here you put in a replacement cost and just a policy on when you want to replace the asset, and there's some other parameters that you can put in or not put in. The system uses a widely contribution to calculate the average annual agency user cost, considering the possibility of asset failure as well as the sort of annual maintenance cost. And then again, you get prioritization data, same sort of information as you got from the vehicle tool that shows you what the priority of replacing the asset is over time. Condition-based tool here, again, we found data from TAM to feed the models, and we used a modeling approach of doing Markov decision models that you see a lot on highway side, particularly for bridges, to develop the condition data. So essentially, you choose an asset, you put in rehab and replacement costs, and then the system will give you back average annual costs, again, similar to what you saw in the other models. And here, we don't have an age where you should replace the asset, because it's not an age-based model, but there's a condition threshold, and by default, we use the term 1 to 5 condition rating, but a condition where you should perform action and what the priority is of performing action by condition. And then finally, there's a prioritization tool where you put in a start year, you enter a budget by year, and then you put in a list of projects, and essentially you have to copy information from the other models. That's the downside. And then out of that, you get a ranking of the list of projects. Just to wrap it up, the results of our research are intended to help transit agencies better prioritize transit capital asset rehab and replacement, and also better communicate what the impact of a particular investment level is. I gave you a brief preview of what's going to be in the report. That report will have everything we presented here, review of the SGR materials, this discussion of relating SGR performance, the framework and all the process steps in that, and then the supporting tools. That's it. I'd be happy to take any questions.
Will there be a robust lexicon in the FTA Asset Management document? For example, MDBF can be defined a number of ways to include if the delay time is above some threshold, or if the car or train did not complete its trip, etc.
We're not being prescriptive with definitions. In fact, what we're stating in the manual is that it's important to have definitions for these things, but we are not putting that out for the industry.
Yeah, and certainly in our TCRP report, we didn't try to define standard measures either. But it's a good point, and we saw, in particular at NDBF, a lot of differences in how agencies define it.
Yeah, I would say the same for measuring state of good repair or defining state of good repair. The FTA actually explicitly told us not to define it. That's really up to an agency.
Is the MTC area for national agencies using age-based or condition-based criteria for tracking SGR? Which method is more prevalent?
Yeah, that's an excellent question. I would say that NCC's models are based on age, and nationally, almost all of the models that you see are based on age. Look in TAM, it has models that show the deterioration of an asset over time. They look like they might be condition-based models, but in fact, we just don't have very good data nationally on condition. So in TAM, the condition of an asset is predicted based on its age, so essentially it ends up being an age-based model. So I'd say, definitely for lack of data, age-based models are certainly the most common. There are some examples for vehicles of mileage-based, and a lot of maintenance work on buses, for instance, is based on miles, not age. So miles, in the case of vehicles, or age, in the case of other assets, would definitely be the most common. What you see in other industries is that for very complicated assets, age is just not a very good predictor, and so for facilities or for bridges, it's much more common to use condition-based measures, or if you are using age, break the asset down into subcomponents and characterize the age of subcomponents if you're going to use an age-based model.
Are the modeling tools proprietary or available for free? If free, where, how can they be obtained?
Yeah, that's a great question. Since these are done as part of a transit cooperative research project, everything that we did is going to be available for free. So it'll be an Excel spreadsheet, and it'll be on a CD or a DVD that comes with the report, but then TCRP has told me that they'll be able to put it put it online and people be able to download it. So, I'd say keep an eye on the TCRP site for an announcement. In terms of what you'll get if you do the download, it's a set of 4 different Excel spreadsheets. They're Excel 2007 format, and we tried to make it so that they're as user-friendly as is reasonably possible. If you want to get into the guts of them, you'll see that, for instance, the spreadsheets are locked, but you can just go unlock them. There's no password or anything like that. So our intention is to try to make all the stuff we did as available as possible.
Definitions continue to be problematic when hoping for standardizing NTD data on which many reports are based.
That's a great comment. Definitely, in our modest research project, we were able to bypass some of those issues. But as we saw with NDDF, there's a lot of issues with definitions and how different things are reported from agency to agency. So we have national defaults for the term models, but I would hesitate to boldly predict any of these sorts of models that you're showing to work consistently from one agency to another. In our vehicle model, we have you put in your own fleet information, your own data on number of failures, so however you define failure. I think it's important, given that there are so many inconsistencies, that if you're going to use tools and models, that you be able to tailor them to your own needs. But certainly, we're aware that there's a lot of definitional issues out there, and it wasn't in the scope of our effort to try to address them. But I know that FTA is certainly aware and interested in addressing some of those issues as a separate matter.
Are the prioritization models just discussed intended to be used instead of the prioritization provided by Term Light?
Oh, that's a good question. I would say that they're kind of 2 different things. Now, in Term, FTA is working on enhancing the functionality of Term. But in Term Light, the version that you can download, there is, the prioritization is somewhat limited. For state of good repair, you set a policy of when you need to rehab or replace an asset, and then Term does it, and then you can test what would happen with different policies. You can say, okay, 2.5 is our threshold for all assets, or you can go in there and tweak it and say, okay, you know what, for rail, let's set the threshold 2. There's not really much else, in my understanding, for prioritization in Term Light, but there is prioritization in Term for improvements. So I was just talking about state of good repair, and I know that FTA is interested in enhancing Term to change its functionality. So I would say Term is answering a different set of questions and has different functionality from the tools we developed. We weren't trying to undo or redo Term, but what we did use from Term are the deterioration rate for the assets. And that's really the best available data on how long does a turnout last, or how long does an elevator last. So we use that sort of information. But if you have a reason to definitely use it, these tools are trying to answer slightly different set of questions from what Term would do.
Adopting transportation asset management has been described as moving from a worst-first approach to prioritizing investments to a more efficient approach that considers risk. Can you describe and give an example of how this improves outcomes and what the trade-offs are?
Well, that's a great question. I would say that if you're working with age-based models, it's a little hard to do this, but certainly once you get into condition-based models, you can see this pretty clearly. In the report, we give an example of an escalator model. And actually, there's a great research paper we found from Hong Kong on modeling life cycle costs for escalators. And in it, they go through and they sketch out exactly what you can do to an escalator over its life and how much this costs. And essentially, we plugged all those numbers into the condition-based model, and the model put a pretty high priority on rehabbing the escalator when it was in a marginal condition, and that, prior to it getting, having to replace the elevator when it got to a very poor condition. If you think about it, That's the kind of thing you're looking for when you start talking about this issue. If you just wait and you only replace the escalator when it gets to the worst possible condition, now you're going to be stuck rebuilding the whole thing, and that thing's going to be closed for months, and people are going to be taking the stairs or diverting people to other stations. And if only you rehabbed it before you got to that point, you'd save a lot of money. So we saw that, an example of that in the example, this escalator example. You can find examples of like this all over the place. That said, a lot of these models, it's not that complicated. If you've got vehicles that are getting same miles every year, and they're a range of different ages, which one are you going to replace first? You're going to replace the oldest one first. So you don't always see replacing the oldest asset. Often is the most reasonable thing to do. It's not always the most reasonable thing to do. We're trying to provide a set of models that allow you to look at these questions, but what actually the optimal thing to do depends a little bit on the asset and on the inputs you provide the model.
From an organizational viewpoint, what position or skill set typically formulates the comprehensive metrics identifying the SOGR rating for all asset types across departmental boundaries?
Oh, that's a really good question. David and Lauren may have something to add on this one from their work on the Transit Asset Management Guide. But in terms of our research, oftentimes when we did the interviews, we would end up talking to the chief engineer at an agency. But really, there's no one position I would say really captures this. In some agencies, particularly larger agencies, we would end up talking to somebody in capital planning who's trying to synthesize the information they get from the different engineering disciplines. In a smaller agency, typically chief engineer, but it's all over the map. And I don't know, Lauren, David, do you have anything to add on that?
Yeah, I can tell you what we're suggesting from a best practice perspective would be that the way that the metrics that you track, you want them to ultimately support the agency's overall goals. If you kind of start at the top, you want your general manager and executive team to be setting what those overall agency goals are and agency performance metrics. And then it's a matter of talking to the asset owners, and these are the people that are responsible for managing across the full asset life cycle. So it's going to vary across different agencies on if that person is in engineering or maintenance, or it could even be finance people, but whoever that asset owner is should create a set of metrics that ultimately help to support those overall agency metrics.
This is another good reason for enhanced communication between fleet managers, transit finance, and planning folks.
Yes, I couldn't agree more.